Hello all, I'm Rishabh Srivastav, Code India Fellow at Navgurukul, and here we are with another problem, which is this one, finding the sum of these three series. So we'll be discussing all of these three series by dividing them into three parts. The first part will be understanding the question, the second part will be understanding the logic, and the third part will be implementing the flowchart of it. So let's begin. The first series is this one. Before that, we need to understand that in the question, we are given two inputs. First one is x and the second one is n. N is the number of terms and x is the value that we have to put in this series. Right. So let's look at the first series very closely. It, it is x plus x square by 2 plus x cube by 3 plus x to the power 4 by 4, and this will go up to n. So if there are n terms, the final term will be x to the power n by n. So we have to find the sum of this series. So to find the sum of this series, the first thing that we have to do is to find a pattern that is getting repeated in all of these terms. So what is that pattern? Can you guess? So let's see. The first term is x, which can be also written as x to the power 1 by 1. The second term is x square by 2. The third term is x cube by 3, and like this the nth term is x to the power n by n. Okay, so do you see a pattern that is getting repeated here between the term number and the actual term? Can we say that if the term is I, if it is the ith term, then the term will be x to the power I by I, right? This is the key observation that we need to do to find the sum of the first series. So let's see how will we implement this into flowcharts. For this, we need to maintain two variables, which will be numerator and denominator. Before that, we need to take input of x and n. After this, we'll initialize two variables. One will be numerator, which will be x, and another is denominator, which will begin with 1. And we'll run a loop until n times. So we'll run this loop until denominator is less than equal to n. Of course, and we'll take another variable which will be the sum. This variable will contain the total sum, so we will initialize it with 0 and we will keep adding each of the terms in this variable. So in the beginning of this loop, the first thing that we will do is that we will add numerator, we will add numerator by denominator into the result. And after that, what should we do? Let's look at this series again. After that, the denominator is incremented by 1. With each term, denominator is getting increased by 1. After this, it will become 4. After this, it will become 5. And up to n. When once it exceeds n, the loop needs to stop. And the numerator is getting multiplied by x every time. First, for the first term, numerator was x. For the next term, numerator became x square. And for the third term, numerator became x cube. So, can you see that it is getting multiplied by x with every term? So, this is the modification that we need to do, or updation that we need to do with each term, right? So, we need to multiply numerator with x and increase denominator with 1, isn't it? After that, we'll go back to the loop. And once we come out of the loop, we simply have to print s, which was the sum that we calculated. So this is the solution for the first problem, for the first series. Now let's look at the second series very closely, which is this one. Here also we have two inputs, which is x and n, and the series goes like this: x minus x cube by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus x to the power 9 by 9 minus x to the power 11 by 11, and it goes up to n terms. N terms. Right. So now we need to figure out a pattern in this series also. So let's see. The first term is x, which can also be written as x to the power 1 by 1, and the second term is x cube by 3. Third term is x to the power 5 by 5, and fourth term is x to the power 7 by 7, and it goes like this. So what is the pattern that we can see here? Between numerator and denominator, we can clearly see here that the numerator is getting multiplied by x twice every time. It was x to the power 1 in the beginning, after that it became x cube, which means it was multiplied with x square, and again it was multiplied with x square, and again it was multiplied with x square. So this is the pattern that is getting followed in the numerator. And now let's see denominator. It goes like this: 1 3 5 7 9, and up to n terms, right? So what's the pattern here? The denominator is getting increased by 2 every time. So this is what we have to do for n terms. So how will we do that? This is the logic. Now let's look at the flowchart of it. Same thing we'll do, but we'll just introduce another variable, which is our old friend I, which will start with 1, and numerator and denominator will be same. Numerator will start with x, denominator will begin with 1, and there will be a variable which will contain the final result, which is s. After that, what should we do? We have to calculate the sum of n terms, right? So we need a variable which will go from 1 to n. Previously we used the denominator itself, because denominator was getting incremented by 1, and it was also starting with 1, and it went up to n. So we directly use the denominator variable for the counting of loop. But here the denominator is getting incremented by 2 every time, so we cannot use denominator for the looping. So that's why we have introduced a new variable, which is I. So we'll run the loop until I is less than equal to n, because there are n terms, right? And we'll add the term which is numerator by denominator. Before that, there is one more thing. Before that, there's one more thing, that it's not getting added every time. It's not getting added every time. It is getting added alternatively, and it is also getting subtracted alternatively. So we also need to take that into consideration. So there is another pattern between uh, getting added and getting subtracted, which is that for if the term number is odd, it is getting added, and if the term number is even, this is second term, 2 is even, so that's why it is getting subtracted. And again there is odd term, so it is getting added. Again there is even term, so this is getting subtracted. So for odd terms, add into result. Even terms, subtract. So we need to take that into consideration also. So before adding or subtracting to the final result, we need to check that also whether the term number is even or odd. If the term number is even, if it is even, then what we have to do? We have to subtract the term from the result. S is equal to S minus numerator by denominator. Not like this, numerator by denominator, right? If this is true. And when this is false, we have to add the same thing into the result. S is equal to S plus numerator by denominator. And after all of this, we need to update the value of denominator and numerator. So how will we do that? Numerator was getting multiplied with x square every time and denominator was getting incremented by 2 every time. So let's do that. Numerator will get multiplied with x square, which means x into x, and denominator will get incremented by 2, right? So this is the flowchart for the second series. This will go back here again. And once we come out of this loop, we simply have to print the value of s. Of course, stop the program also. Right. I hope the second series is also clear. Now let's come to the third series. This is the third series. Now let's look at this closely and try to figure out some patterns. Let's write it here. X minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus x to the power 9 by 9 factorial minus x to the power 11 by 11 factorial up to n terms. N terms. So this is very similar to the previous series, which was the second series, but there is only one difference here. There's this exclamation mark. What does this mean? This means that it is the factorial of that number. What is the factorial of that number? Let's quickly discuss that before getting into the series. So the factorial of a number is the multiplication of all numbers from 1 to that particular number. If we are talking about 5 factorial, then it will be equal to 5 into 4 into 3 into 2 into 1, which means multiplication of all numbers from 1 to 5. We can also write it as 1 into 2 into 3 into 4 into 5. It's the same thing. If we are talking about 11 factorial, it's the multiplication of 11 into 10 into 9 into 8 up to 1. Multiplication of all terms from 1 to that number. N factorial is the multiplication of 1 to n, right? 1 into 2 into 3 into finally n. This is n factorial. So this is factorial. So let's see how we can calculate the factorial into our answer. We need to figure out some patterns in this series also. So let's look closely at this. The first term is x as usual. The second term is x cube by 3 factorial. The third term is x to the power 5 by 5 factorial. The fourth term is x to the power 7 by 7 factorial, right? So what's the pattern that is getting repeated here? For the numerator, it is exactly same as the previous series, which is it starts with x for the first term and it keeps getting multiplied with x square with each term. For the second term, it becomes x cube. For the third term, it becomes x to the power 5. For the fourth term, it becomes x to the power 7, right? So we just have to do the same thing that we did in the previous series, which is to multiply the numerator with x square with each term, right? So there's one difference in the denominator. It's factorial. So how can we keep the factorial with us during each of the terms? So for the first term, the denominator is 1. For the second term, it is 3 factorial, which is 3 into 2 into 1. For the third term, it is 5 factorial, which is 5 into 4 into 3 into 2 into 1. For the fourth term, it's 7 factorial, which is 7 into 6 into 5 into 4 into 3 into 2 into 1. Right? So how can we keep this with us? How can we maintain the factorial of each term with us? So for this, what we will do is that we will keep a separate variable f, which will be the current factorial. For first term, f will be 1, which means we are right now we have 1 factorial, which is 1 itself. For the second term, f will be 3. For the third term, f will be 5. For the fourth term, f will be 7. This is just to keep in check what's the denominator. F will denote that we have f factorial in the denominator right now, which will help us in calculating the factorial itself. So let's implement the flowchart for the series. In the beginning, we'll take two inputs, which is x and n. After that, we have to initialize a few variables, which is I equals to 1, numerator is equal to x, and denominator equals to 1, and result, which will be stored in s, it will be 0, and one additional variable f, which will be equal to 1. You will understand this once we discuss the flowchart. After this, what we'll do is that we'll run a loop from I equals to 1 until I is less than equal to n, because we have n terms with us. For each term, again, it's not getting added in each term. We have to first add it, after that we have to subtract it, after that again we have to add it, and again after that we have to subtract it, which means that for odd terms we need to add, and for even terms we need to subtract. So for this also we need to apply the condition. If the term is if the term number is even, which means if I mod 2 equals to 0, if this is true, then subtract the term, which is numerator by denominator. And if this is false, which means if the term is odd, if the term number is odd, we need to add it into the result s plus the term, right? And after this, we need to do the updation of all variables. So what will be that? For the numerator, it will be exactly same as the previous one. Numerator equals to numerator into x, which is this is basically x square, right? So we are multiplying numerator with x square. And what should we do with our denominator? Let's try to figure this out. What should we do with our denominator? Denominator for the first term is 1, and f is also 1, which means we have 1 factorial. If f is 1, it means that we have 1 factorial with us right now. And after that we need 3 factorial. 3 factorial. So what's the relation between 3 factorial and 1 factorial? What's the relation between them? Let's see, what's the relation between n factorial and n minus 2 factorial? If we have n minus 2 factorials, can we calculate n factorial? Let's understand this with an example. Suppose if we have 7 factorial and after that we need to calculate 9 factorial, how will we do that? Let's write the factorial of 9, which is 9 into 8 into 6 into 7, 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so look at this separately. Look at this. Forget about this part. Just look at this. Isn't this 7 factorial? Is it? This is 7 factorial. So we can write that 9 factorial is equal to 9 into 8 into 7 factorial. Isn't it? So to get 9 factorial from 7 factorial, we just have to multiply it with 8 and 9. So the same thing we'll do here also. We have 1 factorial, now we have to calculate 3 factorial. Or we can see that right now we have f factorial and we have to calculate f plus 2 factorial. So we just need to multiply it with f plus 1 and f plus 2, right? F plus 1 and f plus 2, isn't it? So what we will do here is that we will just multiply denominator with f plus 1 and f plus 2, and after that we'll increment f by 2, because for the next term it will be 3 factorial and it will get incremented by 2 every time. So with this we have got a flowchart. This will go back to the loop, and once we come out of the loop we simply have to print s and stop also. Okay, so this may be a little bit confusing, so let's do the dry run for this one. In the beginning, we have I equals to 1, numerator equals to x, denominator equals to 1. In the beginning we have I equals to 1, numerator equals to x, denominator equals to 1, f is equal to 1 and s is equals to 0. Suppose n is equal to 4. So first of all we'll check that, we'll come to this condition, we'll check that if I is less than equal to n, I is less than equal to n, right? It is less than, right? And one more thing which I forgot here is that I will increment I also, I equals to I plus 1, and for the second flowchart also we need to increment I every time, I equals to I plus 1, which is very important, otherwise we'll be stuck inside nested loop, right? So I equals to 1, and we'll check if I is less than equal to n. 1 is less than equal to 4, exactly, so we'll go into the true condition, which is this one, true. So after that we'll check if I mod 2 equals to 0, so which is false, so we'll come here, s is equal to s plus numerator by denominator. So we'll increment s with numerator by denominator. Numerator is x, denominator is 1. So we'll increment s with 1 by 1, I mean x by 1, right? And after that what we will do, after adding the answer we need to multiply numerator with x into x. So numerator will become x square, x cube after this, because we are multiplying x 2 times. And denominator, what will denominator become? F was 1 and denominator was also 1, so we are multiplying denominator with f plus 1 and f plus 2, so denominator was 1, so it will become 1 into f plus 1 into f plus 2. F plus 1 is 2 and f plus 2 is 3, so it will become 1 into 2 into 3 after this, which is 3 factorial. And after that we'll increment f by with 2, so f will become 3, and after that we'll also increment I, so I will become 2. Again, We'll come to the beginning of this loop. It will check whether I is less than equal to n. So 2 is less than equal to 4. This is true. So we'll come here. Before that, we will add or subtract depending on the term number into the answer. So we'll check if 2 is divisible by 2, whether it is even. So yes, it is even. This time it will go here in the true condition and it will subtract numerator by denominator. So it will subtract numerator by denominator. Numerator is currently x cube and denominator is 3 factorial. So this will get subtracted. And after that we need to do this updation. Numerator is getting multiplied with x 2 times, so it will become, numerator will become x to the power 5, right? And denominator is getting multiplied with f plus 1 and f plus 2. So f is 3, denominator right now is 1 into 2 into 3. So this will become 1 into 2 into 3 into f plus 1, which is 4, and f plus 2, which is 5. So this will become, denominator will become this, which is basically 5 factorial, and after that f will become 5 because we are incrementing it with 2, and I will become 3, right? So again, we'll come to the beginning of this loop. We'll check whether I is less than equal to n. I is 3 right now and n is 4, which is true. So we'll go here. We'll check whether I is divisible by 2, which is false, which means we need to add numerator by denominator into s. Right now, numerator is x to the power 5 and denominator is 5 factorial. 5 factorial. After adding, we'll come here again. We'll multiply numerator with x into x. So numerator will become x to the power 7 this time, and after that we'll multiply denominator with f plus 1 and f plus 2. F is 5, so denominator will become, previously it was 5 factorial, and we'll multiply it with f plus 1, which is 6, and f plus 2, which is 7. So this will become 7 factorial, right? And f will become 7 now. After this, I will become 4. Again, we'll come to the beginning of the loop. We'll check whether I is less than equal to n. I is 4 and n is also 4. So 4 is less than equal to 4, which is true. So we'll again come here and check whether I is now divisible by 2 or not, which is true. 4 is divisible by 2. So now this time we will subtract this answer. We'll subtract numerator by denominator. Numerator is right now x to the power 7 and denominator is 7 factorial, right? So this is what will happen. After that, again we will update the value of numerator and denominator. X to the power 9 it will become, and this will become 9 factorial. F will become 9 and I will become 5. After updating the values, it will again come to the beginning of this loop and check whether I is less than equal to n. So whether 5 is less than equal to 4, this is false. So it will go outside the loop and print the value of s, which was this, which was the required series, right? So we have got our answer. So this was the solution for the summation of these three series. If you have faced any type of difficulty during this video, feel free to comment your doubts. I'll be very happy to solve them. I hope you have understood, and thank you.